We are on paper from 2019, the IGCSE Edexcel paper, and what we're doing with this is we're going to do, firstly, this question. So the 25th term of an arithmetic sequence is 44.5. Now an arithmetic sequence looks like this. A is the first number, A plus D is the number plus the difference, A plus 2D is the third term, etc. So we know that the 25th term is 44.5, so we know that A plus 2D equals 44.5. Then the sum of the first 30 terms of an arithmetic sequence is 765. And on the front of your paper you will find this. So it says sum, so that's 765, equals, and it is the number of the terms over 2 times the beginning term times 2 times n minus 1 times d. So we'll just fill those in, or what we know of those. So we know that 765 equals 30 over 2, 2a plus 29d equals 765, which is 15 times 2a plus 29d equals 765. Aha. I think I'm a little tired, 765. Now, let's check whether 765 is divisible by 15. I think it might be. That's 51. So we know that 2a plus 29d equals 51. And we know that a plus 2d equals 44.5. So we'll times this by 2. That's 2a plus 29. Oh, good Lord, plus 2d. Oh no, it's 24d. That's what's confusing me. Okay, I'm just going to rub this out. It's 2a plus 24d equals 44.5. So that's 48d equals 89. Let's take this one away from that one. And we'll get 89 minus that is 838. And that one is 8, that's 19d. That means that if we divide both sides by 19, we'll get d equals 2. And then we'll put that into the easiest one, which is a plus 24d equals 44.5, and we'll get a plus 48 equals 44.5. Take 48 from both sides and we'll get a equals minus 3.5. Now, we actually need to find the 16th term in the arithmetic sequence. So the 16th term would equal a plus 15d. And that would equal minus 3.5 plus 30 equals, and let's just do a little thing, so that's minus 3.5 plus 30 equals 26.5. And that is your answer, so you need to pop that into there. But don't be afraid of a simultaneous equation, but do try and make it easier. Okay, so this says a equals 25 times 10 to the power 14n, where n is an integer. Okay, find your expression in terms of n for a 3 over 2. So that means a 3 over 2. Oh, we've got to give our answer in standard form. I would have completely forgotten to do that. A equals, and that would be a to the half cubed. And the way we could represent that is a in square root cubed. So that means we basically need to do that. A to the 3 to the 2 equals the square root of 25 minus 10 to the 14n cubed. So the square root of 25 is 5, and the square root of 14n would be 14 times half, which is 7. And we've done one little bit of it, but we need to now cube it. So 5 times 5 cubed is 125, and 7 cubed, or 7 times 3, is 10 to the 21n. Now the problem is that is not in standard form, because in standard form this number has to be between 0, or rather 1 and 9, well, and 10. It's got to be smaller than 10 and greater or equal than to 1. So we're going to make it 1.25, and then we're going to go times 10 to the power 21n plus 2, because we went 2 spaces that way. So that is our actual answer. Next, sorry, just said that in a very sort of grown-up way. So next is 21, and the curve has an equation y equals fx. There's only one maximum point on the curve, and the coordinates of this maximum point are 4, 3. So if we were to do this, it's some sort of minus negative quadratic, and that point there is 4, 3. So we know this is the x point and that's the y point. And here we say y equals fx minus 5, brackets. Now anything that's within the bracket influences the x. So it means that if it's in the bracket, it's either going that way or it's going that way. And when you look at it, you think minus. Minus on the x would go that way, wouldn't it? Well, weirdly, it doesn't. In this case, the x to the minus 5, the way that you make this bracket worth of work, or make it 0, is by making x 5. And to make it x 5, you have to move it 5 that way. So in fact, what you're doing is you're moving x, the 4, up 5 plus 5. So that means that the x is 4 plus 5, and the y remains the same, so it's 9, 3. Now, the second thing is that you've still got the 4, 3, but in this case, the 3 outside the brackets, outside the fx, means it influences the y. So it's like saying 3 times y. So what is 3 times 3? It's 9. So we're going to go up to 4, that stays in the same place, comma 9. Right, here's the graph of a sine bx degrees, and it's between 0 and 360. Now the issue for me here is that that is not a sine graph at the moment. The reason it's not is that a sine graph only goes between 1 and minus 1. It goes up to there, goes through there, goes down there, and it goes down here. So you have to do any of these things, just draw in what the graph should look like. Looks like that. Well, it would do. There we go. So our first issue is that the graph goes down, which means it's not just sine, it's going to be minus sine. My second issue is it doesn't just go to 1, it goes to 2. So it's going to be minus 2 in front of the sine. So a equals minus 2. Now my third issue is this only peaks once in the 360 between 0. Its frequency is just 1. But actually the frequency of this one is 1, 2, 3. So it means that the b bit that influences the x is going to be 3x. So that means a is minus 2 and b equals 3. And that is your answer to that, minus 2 and 3.